Good morning. Welcome to the last lecture of the course Advanced Green Manufacturing Systems. We are discussing developing green factory using unit green manufacturing processes. We have discussed how do we conduct the live experiments. One of the examples which I took on drilling, green machining, that is green drilling. Then we went to factory simulation. We picked that data and went to factory simulation. For you to appreciate, I have put certain points in the presentation here. What we have here are the activity times for the processes. These are the activity times which were chosen for the processes. These times are recorded, as I said in the previous lecture, when we did the sensitivity analysis. We conduct 5 experiments and we noted the setup and processing times for them, and they were then averaged, and these average values were taken here as input for the processes milling, drilling, grinding, inspection. This is our line 1 and line 2 had micro machining and inspection. This n is for normal distribution. You can see the mean or mode value. In the triangular distribution, we have mode value. This is mode value, this is mode value, this is mode value in the triangular distribution. These are mode values. I have discussed a little when do we use normal distribution and when do we use triangular distribution. Because the processes were automated, the machining processes, we chose normal distribution. We did not had a large amount of data or lack of knowledge distribution, that is triangular distribution is selected for the inspection and micro machining and any of the processes that involves human actually. So, this is taken from the simulation experts, like there is a book by Law and Kelton. Okay. This is a book by Law and Kelton. In this, which distribution to be select and the usage of triangular distribution and some other distributions like beta, uniform, that is given here. So, when human operator dependent processes are there like inspection, we chose triangular distribution. Okay, these are the times which were put in the simulation that we saw in the recent lecture. This is the criteria of worker selection. I told you that we select 4 workers. Finally, we started with 6 workers, that is 1 worker per process, but we came down to 4 workers. And I also told you that this difference, if we choose 5 workers, this difference is only 4.7% in the productivity in line 1, and in line 2 this difference was 7%. So, you can see 5 and 6 workers are giving exactly same throughput, in 5 and 6 workers. With 4 workers there is a little fall, but after 4 workers the fall is quite high. So, this might be around 20 to 30% decrease if we get 3 workers here. So, 4 workers was the best alternative that is selected here. So, this is just the diagrammatic representation of what we saw or what we decided in the simulation that we conducted in the last lecture. So, that was the experiment manager which run, and we saw the simulations, and we had 25 experiments and 50 observations for them, and we had this kind of throughput that we have seen. In this throughput, we saw that the mean is higher in line 1, the mean is lower in line 2. Another way to look at the throughput is like this. We draw the normal curve for them. So, this is normalization check. In normalization check, we observe that the data is left skewed. You can see there is skewness. This is not at the center. Data is left skewed, and the data is behaving quite well in throughput line 1. and in line 2 the behavior was not that good, like you can see this difference. This was again due to the small number of components which are manufactured in line 2, and also as we discussed that the mean or the standard deviation is here, the standard deviation was around 4.5 units, sigma equal to 4.5 units. Here standard deviation, or I will just put sigma here, this is equal to 1.5 units, which here was around 2.5% of mean. Here it was around 11% of mean. So, this is normalization check for the throughput in green factory. So, this is how we develop the green factory, and also as I said, we can take this data to team center to decide for the vendors and to where to purchase, where the product go, those things. That ERP, enterprise resource planning, can be taken in team center. Technomatics just had the plant simulation in it. These are resource utilization charts that we have discussed in the previous lecture. We had the processing and setup times here. This is the processing time, this is brown is a setup time, and also we can see the idle times are there when the thing is working. So, the idle time for workers varied from 1 to 6%, and the remaining time was production time, that is distributed among the operating machine, setting, then up route and down route. So, those times were there. So, these are the times, these we have already discussed. So, just to put in PPT for you to see this. Now, I will summarize my green factory. What did we learn, or what did we do in developing this green factory? We conducted live experiments, or we selected unit manufacturing processes and we conducted live experiment. Right. Now, this experimental data was then statistically analyzed. Analyze the obtained data. So, why do we analyze this data? To identify the significant factors those are influencing the greenness. We identify the significant factors influencing greenness. Right. Then we did optimization, that is, I will actually put, we did ABC simulation. To determine what? To determine the optimum settings of the process parameters. Okay. These were for the four processes, for I would say unit manufacturing processes, UMP. I will put this is UMP, unit manufacturing processes. Now, step 4 was we developed a complete hypothetical flow shop with 2 lines and conducted discrete event simulation. Using a hypothetical factory with flow lines. Now, this is what we did to develop a green factory. So, this is a kind of a pseudo algorithm or the steps that we took to develop a green factory. Now, what did we get from this green factory? We identified that the vegetable oil is suitable for this manufacturing for certain reasons. Human operator is not affected, his health is not affected by this. Number 2, the machining quality was similar, if not better, it was similar to what we can obtain in flood. So, these were the few observations for that, and also we selected MQL which has lesser consumption of fluid. So, we had reduction in cutting fluids, okay, lesser consumption of energy, right. Then we reduced the ecological hazards, that is disposal of cutting fluid and while using biodegradable fluid. Then I will put reduce or reduction in ecological hazards while using biodegradable cutting fluid. And also work environment is monitored. So, at this juncture, while in this specific study, it cannot be claimed that the results are directly transferable, because we have conducted in a specific environment, specific set of you can say specific combination of workpiece and tool, but this approach is obviously transferable. This approach can be used in any set or any combination of the work and tool. Also, in this case we just picked the unit manufacturing processes, we made them green, and then we took them to the factory. We reduced the power consumption, or we minimized the power consumption in the unit processes. This is one of the ways. Another way can be, we pick the machines, take them to the factory, and then we see the overall consumption after this also. That is, there is a feature known as energy analyzer. Energy analyzer. Okay, this is a feature. I will put a line here. This is a feature in plant simulation version 11 and above. We had plant simulation 10 with us, so we did not have this module. For example, in plant energy analyzer, the energy can be monitored, which machine is consuming more energy, like in line balancing. As I discussed, line balancing is when we balance or with the distribution of workers to the machine. No worker should be idle, no machine should be idle, that is known as line balancing. In this case, we distribute the power to the machine, so that the overall consumption or overall load capacity of the factory is lower. For this, I will just add a video just after this. So, you can watch this video that is given by Siemens, that is just an introduction to how do we use energy analyzer. The kind of feature or kind of the function they have in this software, they call it as energy consumption simulation. Okay, this is done using energy analyzer in plant simulation 11 and above versions. So, let us try to see this video and see how energy analyzer and the tools like these can be beneficial, and this is an add on to what we have learned in the previous lectures on green factory simulation. So, let us watch this video.
Energy consumption simulation with Technomatics plant simulation. One of the customer benefits. Do you know the power consumption of your toaster, or that of your washing machine, or your TV? How long are the on times of the devices? Does it pay off financially to buy a new energy-saving device? And when is the return on invest? Industrial companies are wondering about these and similar questions as well, and they have the same questions as most households do. Private consumers usually only know the total energy consumption of their household. However, you can only make the right decisions if you know the individual energy needs, peak loads, and average values. The classical material flow simulation mainly provides information on the output of a plant and shows bottlenecks as well as the influence of product variance on the output quality. In our current version of the Technomatics plant simulation software, however, a module is now available that provides information on the temporal dynamic energy consumption of the production plant. The advantage: in existing production plants, significant energy savings potentials can be revealed. BMW, for example, has discovered energy saving potentials of 3 gigawatts per year in its engine production near Steyr in Austria, and was therefore able to reduce the energy costs. The fact is that the potentials were increased due to improved control logistics, which means without the acquisition of new machines, which is particularly elegant. The potential is even bigger with new plants. On the one hand, new machines can be used more efficiently, and on the other hand, the supply periphery can be adapted more accurately. Large plants cannot simply be plugged in, but need complex reactive compensation units, transforming stations, and electrical buffers against too high starting currents. So far, these plants are mostly designed for a static load with so-called simultaneity factors. The dynamic plant simulation of Siemens displays the real energy consumptions dependent on their actual simultaneously needed resources. Therefore, the expensive oversizing of the power supply hardware can be avoided. This is how our Technomatics plant simulation software helps our customers to save energy and costs sustainably.
So this was Energy Analyzer. With this, our course is complete. We have tried to develop or to teach the techniques those are used to develop the manufacturing systems, the advanced techniques like plant simulation softwares, and some statistical tools are taken. Dr. Deepu Philippe has mostly focused on the statistical tools, how to quantify the greenness. I have focused on the design and value engineering, the qualitative aspects, the subjective aspects. To summarize this course, I have just put what we have covered in the course in 2 slides here. These are the topics that we covered. In the first part, we covered productivity in manufacturing, that was taken by Dr. Deepu Philippe. We saw what is product life cycle. Then we went to introduction to optimization. Introduction to optimization, we saw the mathematical modeling. We saw mathematical and we saw the examples on this. Also we saw the solution using Excel for the example. Solution using MS Excel. In MS Excel, we taught you how to install Excel solver and how to use that, and MS Excel solver then demonstration. Specifically, I'll put here MS Excel solver. It is known as Excel solver actually. Excel solver demonstration of this was given. Then also we saw the value engineering green plan, in which we saw what is value engineering and what is value engineering green plan. So what are various techniques to conduct value engineering, what are the product characteristics, what is fast diagram that we saw, fast diagramming. Then we went to creativity techniques. In creativity techniques, we saw certain techniques like brainstorming, Gordon technique, checklisting, those techniques were discussed. Then after that we had a little discussion on frugal innovation, how frugal is sustainable, and frugal versus quality, frugal innovation versus social entrepreneurship. We saw how is frugal sustainable. Then we went to green quality function deployment. In green quality function deployment, we saw how the voice of the customer can be converted to the manufacturer's requirement. We went through the 4 phases of QFD, and how to inculcate the greenness into this. Before that, we saw what is KANO model and where can we put the green aspects into this, analyzing voice of customers, then product design specifications, concept comparison, preference rating, these things were discussed. Then after this first part of the course, we went to design of experiments for factor selection. Dr. Deepu Philip took this. So here he discussed what are types of systems, the variables in the experimentation process, then experimentation of process schematic, then observational study versus experiments, and factorial experiments were discussed. And also I took response surface methodology RSM here when I developed green factory using green manufacturing processes. Before that, we saw the fundamental techniques of experimentation, in which we saw basic steps of experimentation. Then we saw what is ANOVA, analysis of variance, and what is use of that. The complex experiment, simple example was taken, randomization sequence, then experiment data collection, how to analyze the data using analysis of variance, then various steps for this were taken. Then I went to design for environment. In design for environment, we saw what is product life cycle, that is from design for environment viewpoint, and importance of design for environment. Then waste management, we had a little light on that. Then we discussed about the levels of design and levels of design for environment, and then we saw the environmental and safety review. With this, we went to lifecycle assessment. In lifecycle assessment, we saw what is lifecycle assessment, and 2 tools were discussed. 2 tools or software. Okay, which were EIO-LCA, which was an online tool, and GABI, which was a process based tool, that was discussed. After that, Professor Deepu Philip took the overview of the optimization methods, in which he took the ANOVA table for 2 factors, and then branch and bound search, heuristic and optimization, in which taboo and simultaneous learning method, taboo and simulated learning, genetic algorithm, these were taken. Then I went to the sustainable factory in the last week, in which we picked the unit manufacturing processes. We picked drilling as an example. Okay, then we optimized, the summary is already given in the recent lecture only, and we developed a green factory. This was the example that we took. So this is all in the course Advanced Green Manufacturing Systems. With this, I like to say thank you for being in the course. We had an overwhelming response for you people. We have an exam. Prepare well for the exam. The notes, those are given in the PPT versions of the lectures is already available, and also you can read more on these topics from the books or the suggested material that is there in the course home page. Prepare well for the exams. Ask any questions that you have in the forum. We will be happy, or we will try our best to answer all of them. And with this, I will say bye and thank you so much.